I've done one of these, but we'll go for here. Let's go blue today with our dot. All right, so we're looking at composite functions. So in our textbook, this is section 3A. So our composite functions, if we're thinking of these, I'm just going to really roughly go through the definition. Why is it not letting me shrink? There we go. If we have a function, which we'd usually write f of x, it means that when we put x into it, it turns into f of x, and g of x, such that x will become g of x. The composite function of f and g will convert x into fgx. F of g is used to represent the composite function of f and g. It means f following g. So we've sort of done this before previously, and it means that if we put a function inside a function, so let me just change to blue. So if we're looking at f, if our f function is just 2 times x, so that just means if we put an x in it, it gets multiplied by 2, and then g of x equals square root x, then f g of x means we put that, the x gets square rooted first, so we would then see f with our input then being square root of x, because that's what's going to come out, and then that would be 2 root x. So really quickly going over that. Now, we've not really talked too much about this before, but when we start to do these composite functions, we need to start considering the domain of these functions. So in terms of f of x, the domain has all real numbers, but g of x has to be 0 or greater than 0. Now, one of our definitions here is that the domain of fg of x is the subset the domain of g. So what this means is it means when we work out the domain of g, we can say, well, that's going to equal the domain of f of g. So we're going to restrict that straight away, and we're going to go, as far as we're aware, this domain here of f of g, when we do our composite function, we're going to have, that domain is fine. We can put those values in there. Now, the note here is sometimes we need to restrict more of these values. Now, the range of g of x is going to be the subset of the domain of f of x. So what we think about here is, when we've got our first function, we've got to think about our x value goes into the g function. So first off, we consider our domain of g, and the values we put in there, they're going to come out and they're going to give us a range. So for x here, x goes from 0 to infinity. The values we get out of this square root are 0 to infinity. Now, we then need to consider the range of g has to be the subset of the domain for this to exist. If it doesn't, we're going to have to do some jigging, like some rearranging. So let's go to an example for the minute. So I picked this example, we might have talked about it in class. Our example is we've got f of x equals 9 minus root x, and g of x equals 1 over x squared minus 4. Now I've got the graphs there, so this is what f of x is. We see that it doesn't exist over here. Over here in quadrant 2 and 3, but we've got, it's going to exist from 9 down until infinity. This function here, which is g of x, it exists for all values apart from x equals -2 and x equals 2. So we see we're positive over here, and then in this value we're negative. So I've got these, so the domain of our, this function here is all real numbers, x is greater than or equal to 0. And the range of values is going to be negative infinity up until 9. Now, the domain of this value here of g is going to be all real numbers apart from x cannot equal plus or minus 2. And the range of these values is y is all real numbers. It has to be less than -1/4 or greater than 0. Now, for f of g to exist, we need the range of g to be the subset of the domain of f. So at the moment, the range of g equals all real numbers except for the interval between -1 and -1/4 and 0. And I have stuffed that up. That should be, let me change to a black. That should be a square bracket there, because 0 is excluded. So when you look at this here, there is a range here of g that we're missing, that no value comes out of. Now, other than that, we've got our domain of f needs to be all positive numbers. So at the moment, this bit here doesn't fit that rule. That is outside this domain of f. So therefore, our composite function does not exist over this domain. So then we go back and we go, well, so the domain of f is all real positive numbers. If we could get rid of this section here, let me get the highlighter out. If we could get rid of this bit here, then we would have, our range would be all the positive numbers. So we would be looking at here with that bit gone. If we could restrict it to all the positive numbers, all the numbers above the x-axis, then it would fit in the subset. So if the range of G is restricted to all the positive real numbers, then we would have the range of G is all the positive numbers, and that is a subset of the domain of f, which is all the real numbers plus 0, union 0. Therefore, our composite function would exist. So therefore, what we need to do is we need to restrict the domain of G to be all the real numbers apart from the interval -2 to 2. So this notation means we want to get rid of this bit here. We're going to remove that from our original domain of G, and then our function exists for everything. So we restrict that out. Here I've done the composite function. This is what it looks like. So because of that bit we don't want, we've restricted the domain to these values here. We've got -2 not included and +2 here. So you'll notice them there. I'm going to get rid of them. I think they make my diagram look messier. Actually, let's just undo. And so we then state that that is our domain. So from this, therefore, our composite function here equals this if and only if the domain is all real numbers apart from the interval here. Now, let me just do that. So this is saying our domain is x is all real numbers apart from x has got to be less than equal to -2, not equal to, less than -2, and x has to be greater than +2. And that domain is what we need there. So this is just, therefore, the domains are the same. Once we restrict that domain of G, and then this would be our graph of our function here. You notice it doesn't exist here. It can't be bigger than 9 because our function is going to be 9 take this thing here. So it can't get bigger because as x gets bigger, it's going to just restrict it more. All right, thanks guys.